This is section 6.6, integration by parts. Students will integrate by parts, find a definite integral using integration by parts, and derive a general formula for using integration by parts. So for the beginning here, we want to find the derivative of f of x equals x to the fourth times sine of x. When I look at that, I see two different functions. I see x to the fourth, I see sine of x. I know with derivatives, we have something called a product rule. We would say that f prime of x is equal to the first times the derivative of the second plus the second times the derivative of the first. Something like this. Maybe you factor out x cubed. Doesn't really do much for us. But there you go. There's a factored version of it as well. So we have this product rule for derivatives. Now, we don't directly have a product rule for integrals, but we have the result of a product rule. We use something called integration by parts. So here's the formula. I have two pieces. I have f times g. Well, g prime actually. And when I want the antiderivative of that or the integral of that, it's going to be fg minus f prime times g dx. There's a lot of pieces in there, and this is actually derived from the product rule. You can look it up and work backwards and figure out what it is. I recommend just jumping into memorizing it. Often, instead of using the f's and g's like we have for product and quotient rule, that gets a little cumbersome. So we have u and v. Those are the two variables that we use instead. And this will be the way that I go through the formula. What do they mean? We're substituting again. We're going to have a u value. We're going to have a dv value. So that means that we're going to have the derivative of something, and we're going to have to integrate it. How do we know what's what? We use this acronym, this LIATE, or however you want to pronounce it. Further to the left are usually the u values. Further to the right are usually the dv values. But what do these things stand for? So L is for logs. I is for inverse trig. A is for your algebraic. Think just like x squared, x to the third, things like that. T is for regular trig, and E is exponential. So those are the categories of the pieces that we have and where they could lie. So what does this look like? For example 1, I have x times e to the x dx. X times e to the x dx. So we need to decide what is u. We need to decide what is dv. So when I look on my list here, I see x, that's going to be an algebraic term. I see e to the x, that's going to be an exponential term. So on my list, algebraic, exponential. The one further to the left is usually the u. So in that case, that will be our x. dv then is the other one. That's e to the x dx. So next thing, we have a u. You need du, the derivative of that. I know that's 1 dx. Then from dv, we have to integrate both sides. dv becomes v. The antiderivative of e to the x is e to the x. And yes, there will be a plus c on the end because this one's indefinite. So now what we have to do is plug them into our formula. So the integral of u dv is equal to uv minus the integral of v du. And we'll put in our pieces. So in place of the u, I have x. In place of the v, I have e to the x. Don't worry about the plus c. Minus the integral of v, which is e to the x. And then du is really dx. Now, if you'll notice, we still have an integral symbol in here. We're not finished yet. So we still have to find the antiderivative. So this piece here in the middle is good to go, x e to the x. Minus, what's the antiderivative of e to the x? Well, it's e to the x, and on the very, very end, we have a plus c. So that, my friends, is integration by parts. So a lot of pieces to keep track of. You're finding derivatives, you're finding integrals, you're using the formula. Yes, we have to have that memorized. You might want to write it onto your golden ticket for now, just so it's easy to reference. But all of this does become our answer. All right, derive the formula for the integral of natural log of x dx. So the first thing you want to ask yourself is, do I already have an antiderivative for this? Is natural log of natural log of x the answer to anything? The answer is no, it's not. So we are going to use integration by parts. So my formula is uv minus the integral of v du. If I have my little list here, I have LIATE. Now, I see a natural log, no problem, that's log, but I don't see anything else. But guess what? There is something here. There is a 1 that's being multiplied by the natural log of x that's in the front, and 1 counts as an algebraic term. So when I look at my list, I've got a log, I have an algebraic term, so u is going to be the one further to the left, that's natural log of x. dv is the one that's further to the right on my Liate list. That's what my students always call it in the past. So this would be 1 dx. du is the derivative of natural log of x, so that's 1 over x dx. dv, we have to go up to the antiderivative. The antiderivative of 1 is going to be x. Yes, there is a plus c, but we will deal with that on the end. So when I put the pieces in, I've got natural log of x, v is x, minus the integral, v is x, and du is 1 over x dx. So I'm taking these pieces over here on the right-hand side. These pieces over here on the right-hand side and putting them into the formula. And now what I need to do is go back and simplify. This is not natural log of x squared. They can't be multiplied, but I'll put this in the front. Minus the integral of 1 dx. If I take this one step further, we still have to integrate that second piece. So x, natural log of x, the antiderivative of 1 is x, and there is a plus c on the end. Oh, excuse me, there you go. So integration by parts. You can force that second term to be there. And when I look ahead to example 3, that's exactly what we're going to need to do here as well, because I only see inverse tangent. I don't want the derivative of inverse tangent. You can't tell me it's 1 over 1 plus x squared. But we are going to put a 1 in front of it and try to come up with that antiderivative. So 1 times inverse tangent of x dx. If I look at my LIATE list, I see an algebraic term, and I see inverse trig. Not regular trig, inverse trig. So I know that u is further to the left, dv is on the right. So u is that inverse tangent of x. dv is going to be the other one, which is 1 dx. The derivative of u is 1 over 1 plus x squared. The antiderivative of 1 is just x. Yes, there's a plus c. So my formula is uv minus the integral of v du. In place of u goes inverse tangent of x. In place of v goes x minus the integral of v, which is x. And du is 1 over 1 plus x squared dx. All right, so if I clean this up a little bit, x inverse tangent of x minus x over 1 plus x squared dx. Now you're looking at this part, the second part, the integral, and you're like, oh man, that's not something that's nice and neat on the ticket. What are we going to do to find the antiderivative of that? Well, you're going to go into your bag of tricks that you have for integration, and you're going to try another one, another mini u substitution, where u is 1 plus x squared, and the derivative of that is 2x dx. So du over 2x is equal to dx. We're going to do some substituting on that second piece. This is u on the bottom. This is x. dx is du over 2x. That first piece in red is done. We're finished with it. It just has to go along for a ride. The second piece here, I know those x's are going to cancel out. That 1/2 is going to come to the front. Maybe you want to solve this one on the side and then put it with the first half of the problem. Probably be a little less writing than what I'm attempting to do here. 1/2 du over u. The antiderivative of du over u is natural log of u. plus c. Now be careful because we have u's all over the place. So for this particular u, you don't want the original u that was up here. You want the u that we used for just that second piece, which is 1 plus x squared. I know, there's a lot. So this final answer is x inverse tangent of x minus 1/2 natural log 1 plus x squared plus c. We can assess lots of different integration rules in one problem. Okay, excellent. Number 4, we need u substitution again. So algebraic term, exponential term. I know that the algebraic term is going to be the u and the e is going to be the dv. So for example 4, we've figured out what the u and the dv are. So now we just need to build off of that. So if u is equal to x squared and dv is equal to e to the x, the derivative is going to be 2x. The antiderivative of e to the x is e to the x. So now we need to fill in our pieces. I've got uv minus the integral of v du. U is x squared, v is e to the x minus the integral of e to the x, and du is 2x dx. 2x dx. So when I look at this, I'm going to put the 2x in the front, 2x e to the x dx. This piece on the right-hand side, unfortunately, I don't have an antiderivative for that directly. So guess what? We're going to use integration by parts again. So we've got x squared e to the x minus the integral. I'm actually going to put the 2 in the front. I don't need to mess around with that. Over here on this side, u is equal to x, dv is equal to e to the x. The derivative of x is 1. The integral of e to the x is e to the x. So inside of this, I'm going to use the formula. So uv minus the integral of v du. U is x, v is e to the x minus the integral of e to the x, and du is 1 dx. Now we're getting somewhere. X squared e to the x. Definitely did not leave enough space here. That's okay. So x squared e to the x minus, I'm going to distribute the 2. 2x e to the x plus 2. And then the integral of e to the x is just e to the x plus c. Now, if you distribute the 2 to the c, and I think we've discussed this already, it's still just a constant. That c, that plus c, is going to absorb the 2. So I call this x squared e to the x minus 2x e to the x plus 2 e to the x plus c. Not 2c, but just plus c. There we go. Nice job. All right. Cruising right along, example 5 here. I'll switch colors so they don't get stuck together. E to the 2x and cosine of x. I know this is an exponential. I know that this is a trig. This should be the u. This should be the dv. So remember, we're LIATE. We've got exponential and we've got trig. These are both as far right as you can go. I think that's going to present an issue for us. I think that's what this example is going for, but let's give it a go. Let's do what we would normally do. So u is the cosine of x. dv is e to the 2x. The derivative of cosine is negative sine. The antiderivative of e to the 2x is e to the 2x. And then divide by 2. That's because there's a u substitution that's happening in there. So what do? We need our formula, uv minus the integral of v du. U is equal to cosine of x. V is e to the 2x over 2 minus the integral of e to the 2x over 2. And then du is negative sine of x. I'm going to put a negative out here. Sine of x dx. So 1/2 cosine of x, e to the 2x, plus the integral, I'm going to put the 1/2 in the front, e to the 2x, sine of x dx. All right, it's the original problem, and we've gone through and we've done integration by parts once. But if I look at this piece on the right-hand side, bad news, I still have the integral and I have nothing to solve that with right now. So we do need to do another integration by parts over here on the right-hand side. Now, things are going to look kind of similar. This time u is sine of x, dv is still e to the 2x. The derivative of that is cosine of x, and v is going to be e to the 2x divided by 2. So 1/2 in the front. When I go to do the formula, uv minus the integral of v du. So in place of u goes sine of x. In place of v is e to the 2x over 2. Minus v is e to the 2x over 2. And du is cosine of x dx. And maybe you can tell already where this is going. Going crazy. It's driving me crazy, that's for sure. 1/2 of all of this. Okay. Now, here's the thing. Still don't have an answer. We could do it again. And every time I do one of these iterations of integration by parts, the problem's getting longer and longer and longer. But watch this. If you look, there is a piece that is starting to look rather similar. My original problem was e to the 2x cosine of x. Over here, we have e to the 2x cosine of x. Yes, there's an extra 1/2 in here. Those are like terms. Like 2x and 2x, or 2x and 4x, those are like terms. Or x to the 6th and x to the 6th, those are like terms. So the integral of e to the 2x cosine of x dx matches the one on the left. You can actually add this piece to the left-hand side. Now, I feel like I have a sign error here, but I'm going to go with it anyway. If this is a negative 1/2, actually, I should distribute this 1/2 all the way through. 1/2 is messing me up, I'm not going to lie. So if this is e to the 2x cosine of x dx equals 1/2 cosine of x e to the 2x plus 1/4 sine of x e to the 2x minus 1/4 integral e to the 2x cosine of x dx. Okay. So if, and there is a plus c up there that can just hang out. If I take this piece on the right and add it to the left, 1 plus 1/4, so this is going to be 5/4 e to the 2x cosine of x dx. I know, this is crazy. 1/2 cosine of x e to the 2x plus 1/4 sine of x e to the 2x plus c. And then to isolate the integral all by itself, we have to remove that 5/4 in the front, and that means multiply by 4/5 all the way through, and then you have an answer. Yes, it's something you should be exposed to. It's more of a calculus 2 idea that you'd be more likely to see in a college class as opposed to on the AP exam, but it is still something you should know. So obviously I'm out of space. I'm not going to write any more, but that's how you would handle that. So if you get the same thing on the left and the right, you can combine like terms. Again, I feel like I have a sign error or a coefficient error there, but if you ask me personally in class, we can try to figure that one out. Now, integration by parts still works with boundaries. So we can do this with a definite integral. So your a and your b get transferred to the right-hand side of that first piece, and then it's still on the integral of the second piece. So LIATE, SE algebraic, SE trig. I know that U is going to be X, dV is the secant squared of X. The derivative is going to be 1 dx. The antiderivative of dV is going to be tangent of X. So in my formula, U is X, V is tangent of X, minus the integral of V is tangent of X, and du is dx. Looks good. Now, boundaries. I kind of went over that. Now, I know when we learned U substitution in the last unit, you had to change your boundaries, but that is not the case with integration by parts. The formula is set up that it's going to work. It's going to be okay. So this is 0 to pi over 4, and this is 0 to pi over 4. So in the first piece here, pi over 4, tangent pi over 4, minus, luckily, all of that 0. In the second piece, we need the antiderivative. That one's not a straight one that we learned with derivatives, but we did go over in our notes in the last unit. And it works out to be, check your golden ticket, negative natural log of cosine. So I think we called it positive natural log of secant. So minus, and that minus is from the formula. Natural log secant of X. We don't need the plus C, but this is between 0 and pi over 4. So natural log secant of pi over 4 minus natural log of 0. Natural log of 0 we know is the same thing as 1. Secant of pi over 4 cosine of pi over 4 in the denominator. Cosine of pi over 4 is root 2 over 2, but it's in the denominator, so we'll flip it. So it's 2 over root 2, and if I simplify all of that, it works out to just be square root of 2. Sorry, that's all written out. So natural log square root of 2 minus 1. Here's the minus in the front. Pi over 4, the tangent of pi over 4 is 1. So I am going with pi over 4 minus natural log root 2. The idea is you can still use the boundaries. Number 7, find the area under the graph of x ln of x from 1 to 2. So I know area is integral from 1 to 2. Inside is x natural log of x dx. LIATE. We've got log, we've got algebraic. So u is going to be natural log of x. dv is going to be x. The derivative is 1 over x. V is x squared over 2. uv minus the integral of v du. U is natural log of x. V is x squared over 2. Minus the integral of v, which is x squared over 2. And du is 1 over x. There's a dx on the end. A lot of steps in these problems. My boundaries were 1 and 2. This is really a 1/2 x dx between 1 and 2. 1/2, the antiderivative is x squared over 2 between 1 and 2. Okay. So I'm going to multiply the 2 times 2, make it a 1/4. 2 squared minus 1 squared. In the front, this would be 2 squared over 2, natural log of 2, minus 1 squared over 2, natural log of 1. Natural log of 1 is 0. 4 over 2, so this is 2 natural log of 2, minus 4 minus 1 is 3, minus 3/4. Something like that. All right. So we're just reinforcing some of those antiderivative and integration rules that we had in the first part of Unit 6. We're just adding some more steps on there. I know you're going to have questions. Please, please, please reach out. Take your time. Make sure you're not just copying down the answers. This is not the kind of stuff that you can just look at and absorb. You actually have to try it. So good luck, and make sure you ask questions. In this last page, we use LIATE. There was another graphic that I found that was I late, where they switched the I and the L. All right. Good luck, my friends.